Good morning, guys, or afternoon whenever you're watching this. It's 6:30 right now, so it's definitely morning. So we are going to be looking at piecewise functions. I'm going to keep these notes pretty quick for you so that we can get a majority of our practice in class. I'm just going to have a couple of examples of evaluating a function of a piecewise function, one example of graphing, and then one example of writing it. So hopefully this doesn't take too long, and I am really confident that this is going to be the easiest class I've ever taught piecewise functions to. I don't know why, but I can feel it. This is normally not a favorite topic, but I'm hoping to make it a little bit easier. So a piecewise function is just a function that is defined by two or more equations. So if you look at this guy right here, it looks really, really goofy, but all it is just two different lines graphed on the same one. The only thing that's different is each piece of the function applies to a different part of its domain. So for example, this line right here, it's y equals negative x minus 2, so it starts off at negative 2, and the slope is negative 1 over 1. So that's this line right here. But it tells me that this is only if x is less than or equal to 0. So on this x-axis, oh, that bothers me. On this x-axis, when it is less than 0, then that's the line. If x is greater than 0, then y equals 2x minus 3. So it starts off at negative 3, and my slope is 2 over 1. So it's only this line if x is greater than 0. So this kind of gives me a starting and stopping point for where my lines are at. And we'll see some examples in our practice in class of ones that might have 3 of these guys in there, or possibly even more. So let's do just evaluating functions. If you get anything out of this, I hope this is it. It is probably the least fun of all of them. You know, guys probably know this by now, but I'm just kind of nutso about math, and I love piecewise functions. So I really do like the rest of it, but this right here is probably one of the most boring. So I want to evaluate the function. I have f of x. You guys can remember this is y. Y equals 3. That is my graph that looks like this right here. If I have my graph right here, y equals 3 is a straight line right there at 3. It's going to be a horizontal line at 3. So y equals 3. Y equals x plus 2. So I would start off on my line at positive 2, and then my slope is 1, so up 1 over 1. Then y equals 4x plus 0. So I start off at 0, and I go up 4 over 1. So these are all just lines that we have already graphed before, but they give me some starting and stopping points. We're not going to graph this one right here. We're just going to evaluate it. So we're going to try to figure out when x is negative 8, what is y? So if x is negative 8, first I need to figure out where does that lie? Where does negative 8 fit into this right here? Is it less than 2? Is it in between is it less than negative 2? Is it in between negative 2 and 5? Or is it greater than 5? So which one of these does it, which equation does it fit in? So negative 8 fits in this one right here. It is less than negative 2, so we're going to look at this top one. So when x is negative 8, y equals 3. This one has nothing for us to solve. It just flat out tells me y equals 3. Down here, we're going to have to do a little bit more work than that. My answer is 3. For this guy, negative 2. So then I need to figure out, is negative 2 less than negative 2? Is negative 2 greater than or equal to negative 2? So it fits into this one right here. Negative 2 is equal to negative 2. So it fits into the second one. So then I'm looking for y when x is negative 2. Whoops, that second one is a 2 because I have negative 2 plus 2. So negative 2 plus 2 is 0. So on our graph, if we were to graph this and we went to x is -2 right there, y would be 0. So it is the same as on this graph as well. So yeah, it tells you that this is a point that is on the graph, -2, 0, -2, 0. When x is 0, that's in between -2 and 5, so it follows along with this one again, y equals x plus 2. But now x is 0. 0 plus 2 is 2. So if I were to graph this, 0, 2 would be a point. 0, 2, there would be some kind of line going through that point. This line to be exact. All right. On f of 3, so x is 3. Again, that's in between -2 and 5, so I'm going to use this one. Y equals x plus 2, but now x is 3. 3 plus 2 is 5. F of 5. 5 equals 5. 5 is not greater than 5, so it's not this bottom one right here, it's still this middle one. Y equals x plus 2. Y equals 5 plus 2. So y equals 7. And then lastly, f of 10. So x is 10. 10 is greater than 5, so it fits into this one right here. So I'm going to use y equals 4x. Now x is 10. 4 times 10 is 40. So on our graph, if we were to go to +10, we would also have some kind of line going through +40. So we are going to look into this right here in along with a graph whenever we do this in class. I just want to, like I said, try to keep this semi-short. So these are my favorite parts of it, and they might be a little bit on the easy side. So the first piece is graphing piecewise functions, and we're going to do it a bit of a cheater way. So I need to grab a pencil. So the cheating way, which sometimes, I'm not going to lie, is the best way, is to just graph these lines, and then we'll go back and look at this piece right here, because we know how to graph lines. We know how to graph y equals -x plus 2. I start off with my y-intercept at +2, right here, and I am going to go down 1 over 1, down 1 over 1. So I have this line to start off with. And I'm just going to draw a line just like I normally do. Like I said, I'm not going to worry about those these inequalities over here. And there goes the last of the lead. All right. That is karma for making fun of you guys when that happens to you. So I am going to start off with that first line, and then I am going to erase something. It says that it's only this line if x is less than or equal to 0. So this is my x-axis. These are all the numbers that are less than 0. So it only applies if it's these numbers right here. So it doesn't apply for any of these positive numbers. So I can go ahead and erase that. And it stops right there at 0. The next thing I need to pay attention to, does it include 0? And this one does. And just like when we were graphing inequalities, that means it's a closed dot. So I need to make sure that I do have a closed dot there. And I'm done with this one. So how easy is that, just to draw the entire line and erase what we need to? So then let's do this one. Y equals 2x minus 1. So I'm going to start off at -1. And from -1, I am going to go up 2 over 1. And draw a full line. And you guys can kind of tell where we're going to stop. Usually when one starts, the next one stops. So there's my line. But this tells me it's only when x is less than 0, or x is greater than 0. So all these numbers, x is greater than 0, all these numbers, they're not. So I need to erase this piece right here. And then just like the top one, I need to look at my dot. This right here tells me it's an open dot, just like it did whenever we were graphing inequalities. So right there at 0, it should be an open dot. So a pencil is going to be your absolute best friend as you're doing these. I will show you some examples in class where we won't use a pencil and we'll just flat out graph these, and some of you might really like it that way as well. All right, so we are going to write piecewise functions. This is the last one, and we're going to do it really similar to how we graphed it. So I need to come up with some equations. I need to know, what does y equals? What is my equation there? So you can pick any one, but the rule of thumb is when you're graphing and when you're writing, we want to read this like a book. So we're going to start with this line right here, and then we'll do this line. So this line, if I'm writing in slope-intercept form, I notice it crosses at -1. And then I'm looking for my slope now. It goes down 1 over 1. So my slope is -1x. So my graph, or my equation, is y equals -1x minus 1. But this is only when x is less than or equal to 0. Now let's do this line. It starts off at +2. So there's my y-intercept, +2. And my slope is up 1 over 2. Up 1 over 2. So 1 over 2. So there's my equation, y equals 1/2 x plus 2. And it is only when x is greater than 0, not equal to, because it's an open dot, just greater. And we're done. Alrighty guys, I hope that this wasn't too painful for you. I do just want you to take the notes. If you would like to, Khan Academy is a 100% amazing resource for you to watch. You don't necessarily have to do any of the practice problems. We will do a ton of practice in class Wednesday and Thursday. So I hope that this is relatively painless, but I really hope that you have this written down and ready to go for when we have class. All right, see you guys.